Our team set out to design and manufacture a prototype for a toy car which could be efficiently and cheaply mass-produced. With the expectation of children worldwide clamoring over the toy car, an astronomical amount of 10 million units was anticipated to be necessary. With these parameters in mind, using a mold to cast the toy cars was decided on as the most economical manufacturing process. The next major manufacturing decision was the material to use. Since this was our first prototype of the car, we chose to go with the prototype casting material urethane due to the short lead time and low cost. To mirror these preferences, the mold was 3D printed, which is also low cost and low lead time. The prototype toy car was designed with SOLIDWORKS CAD software, then a negative image was subtracted from 2 rectangular blocks in CAD to create the mold halves. Throughout the process, we relied on several of the mold design and casting concepts taught in class. Sharp corners and radii were minimized in the mold to facilitate material flow over the mold walls. Also, we incorporated a core within the mold to prevent material flow within the window section of the car. The pour cup and sprue were designed as funnels, causing the material to flow faster as it entered the mold. We also added additional pouring cavities to act as risers in order to allow more casting material to flow into the mold during solidification. As a final touch, we incorporated tiny air vents within the mold to allow for trapped air to escape when the mold was filled. To rapidly produce a moderately accurate mold for the prototype, additive manufacturing via 3D printers was utilized. PLA filament was used for its low cost. The print layer height and infill percentage were the dominant input parameters to consider. The shorter layer height increased dimensional accuracy and surface finish, which improved the mold shape and ease of removal of the cast. The denser infill improved the structural strength of the mold as well as the probability of a successful print. However, shorter layer height and denser infills increased print times from a few hours to days. A 0.2 mm layer height and a 0.5% infill were used for the mold. Unfortunately, there was a miscommunication between the design and manufacturing team, and the same side of the mold was printed twice. The prototype itself was cast out of a 2-part urethane casting polymer of hardness 60A. The urethane polymer solidified within 15 minutes and achieved 90% hardness after 18 hours of curing. It was very difficult to release, so we developed an ingenious new way to release it from the mold without lube. We put the open areas such as the risers of the cast against flat surfaces other than the holes used for filling. Despite the difficulties, the final product was graciously given a perfect score of 7 out of 7 by Toy Car Magazine. One half of a toy car was produced with poor surface quality, sections sheared off, and mold contaminants throughout the surface layer. Mishaps in the design process include wheels that could not be removed from the mold without breaking the mold, excess unused mold areas, lengthened printing time, and minimal to no draft aid in removal of the cast prototype from the mold. Manufacturing mishaps include misprinting the second half of the mold, rendering casting an entire car impossible, failure to remove all support from 3D print, and not pouring urethane polymer through the designed funnel.